So yes, not to be too awkward to repeat the intro that I just had before, but no, it's really nice to be able to present again. I love doing stuff like this because it's a challenge, and I like to challenge myself. It makes me be better. I get feedback, and I also hopefully get to present meaningful information that can create value in the world. So the other night was my main passion, my main hobby in biohacking. I think it's incredibly important because it's the health of what we are as a population, as a society, essentially creating future generations and how our food decisions impact industry and society and the planet. But tonight is more specifically about climate change, which is a very contentious topic. Everybody has an opinion of it. It's a big problem. It's something we hear about a lot, we think about a lot, but not a lot of people really know much about the nuts and bolts. It is a huge, huge topic, a huge problem, and in one presentation, nobody could ever solve it all or give you a full perspective. So again, as a master's thesis that I wrote this for, you can't just write completely on climate change. With academic science, you have to pick a niche, you have to pick a thread, and you have to dive a little deeper. You've got to kick the ball down the road a bit and further our understanding of things that maybe somebody else has already started. So that was essentially what I tried to do here. For my specifics, what brought me into this was I understand that climate change is arguably the biggest problem humanity's ever faced, and it's most likely the biggest problem our generation is going to have to deal with. Most projections that I've seen, even in the 2 years since writing this, say that humanity has about 11 years left to change the way that we're operating and basically completely get off fossil fuels and change a lot of systems such as agriculture and consumption and transportation, or otherwise it's too late. And we've already preheated the oven to the point where it's going to be catastrophic failure in many of the Earth's delicate systems, ecosystems, atmospheric systems, the way the ocean currents work, and then it's going to be a runaway effect that even if we did completely stop it after 11 years, we're still going to be facing some really, really difficult futures. So for this, you can't solve everything with climate change, like I said, so I specifically wanted to target sea level rise. And the reason why I went for this is because it's one of the most tangible and imaginable effects of sea level rise. Sure, there'll be temperature increases, so it'll get hotter or maybe cooler in some places, because climate change is not always global warming, it's climatic change, good or bad in some places. But it's also, there could be extreme weather events or more droughts or more floods and many other things, the way the seasons change and growing cycles and animal migration. Specifically, I wanted to target sea level rise because it's something that essentially will affect the entire planet. It will not just be regional in scale, it will affect coastlines around the world. So, specifically with this thesis, I've always been interested in the social consequences of climate change. Again, we can talk about the physical aspects of what might happen in the atmosphere or how this temperature might change here, what this looks like. But what's really important to me is how this affects humanity and what it does to us. We are essentially the great drivers of climate change, and we will also be the great losers of climate change. I find that social consequences are interesting because they're very dynamic, they're changing. A lot of this is speculation, as all science and future projections are, but this is also where it hurts the most. We may all care about the rainforests and the gorillas and these other species, but when it starts to displace people and it causes suffering or fatalities or whatever to people, that's when the rubber meets the road, so to speak. So I wanted to try to bridge the gap between the two by utilizing sea level rise and overlaying a social situation and how that might look. So specifically what I was trying to do was quantify the sea level rise projections and the impact of populations at risk from a regional perspective. I couldn't do this for the entire planet. This would be endless amounts of data and so much effort and time, so you kind of have to take a little snapshot, and then from there you can extrapolate how this might be in other places. So the hypothesis of this is that Greater London's current level of hazard mitigation is inadequate to withstand the projected future sea level rise scenarios and will result in increased risk to population at a regional level throughout the 21st century. So I'm going to unpack that a bit, but I always like to present that first as this is where I started. This was what was in my head whenever I had this idea to begin. So the background of this paper, or this research, is essentially a continuation of Dr. James Hansen and his team's work back in 2016. He is known as the father of climate change. He's the guy who is presenting to United Nations. He's made so many speeches. You've probably seen him. You may not recognize him at first mention, but if you look him up, you've definitely come across his work before. He's been doing this for about 30, 40 years, and he is incredibly talented and definitely one of the leading voices that we need to be paying attention to. So this paper was incredibly important, and it basically served as the foundation for what I wanted to do. So he and his team, what they did is essentially they triangulated, which means they took 3 different data sets in a triangle, from atmospheric and ocean modeling, paleoclimate data, and also modern observations of what we're seeing on the ground today. So they took Eemian sea level data. Eemian period is essentially the last interglacial period we had between the 2 previous ice ages. It was from 130,000 years ago to 115,000 years ago. So there's about a 15,000 year stretch between the 2 most recent ice ages. And so what they did here was they looked at limestone platforms, coral reefs, to confirm the different types of storms and other sea level rise, essentially sea level levels, what they were in the Bahamas and Bermuda throughout the Caribbean. They were able to check this based upon boulders that were presented up on the shelf of land, as well as run-up deposits and chevron ridges, which are just fancy, basically carvings into nature that water and other events can do. So just to give a little backdrop of what all this means is, we went to the Underground Museum the other day in Krakow, and you can see the different layers of sediment from the different centuries, right? Like this is something we can easily tell, we can carbon date it, we can measure wind and different atmospheric levels and all these different variables that were happening on the Earth at that time. This is essentially what they've done, but doing it with a water component because they can see where water had put things up into a certain part of land. They also took sediment cores from the North Atlantic Ocean, and they checked Earth's orbital patterns basically to see how much solar influence was affecting the sea level rise. Now again, during this Eemian period, humans are basically a dot on the radar. We have no industry, we're still cavemen. Who knows what the population is, but it wasn't much. So basically humans are not affecting climate at all at this point. So everything that happened during this time was natural, which is completely opposite of what's happening today. So what they looked at here was the CO2 levels in the atmosphere at 1880, which is basically the beginning of the Industrial Revolution, maybe prior to the biggest parts. We're at 280 parts per million. And basically today, or in 2017, they were at 400 parts per million. I think if I'm going to guess, we're about 415 right now, a little bit higher than that measure. It's the first time it's ever been over 400 in the modern world. It's happened a couple other times due to the same scenarios that I was talking about before. But now we have the human influence, which was never a problem before. So if we have 400 part per million on CO2, and we've had this before completely naturally, what happens if it happens naturally and then you stack human interference on top of this? We're in uncharted territory. And essentially the projections, if things continue to go as they are today with our economy and our industry, we're going to be looking at 550 parts per million by the end of the century, which is, you can't even describe what that's going to do to nature. It will be very, very bad if that's what we face. So essentially what they are predicting, Hansen and his team, is that it comes down to all of the variables they looked at, the simulations, everything they've done, a career's worth of work, is that they're pretty confidently predicting sea level rise of 6 to 9 meters, give or take, could be a little more, a little less, within an ecological period. This is about 80 years. So you're talking the rest of the 21st century. This could happen in our lifetimes, essentially. It won't happen overnight. You're talking an inch here, an inch there, a couple centimeters every few decades. But over the course of 80 years, you're looking at a lot. And 6 to 9 meters maybe doesn't sound too big in the grand scheme of things, but if most of our cities are built on the coast, essentially at sea level, what does that do to them? Basically, all of our coastal cities will be inundated at this point. So again, when you do a study, you have to hone in. You have to zoom in on a specific place and try to take a little bite-sized chunk. So I did my homework as far as contemplating places that would be a good fit for this study, and I settled on London for a couple reasons. So it is a first world city, and they are one of the most well-equipped when it comes to flood mitigation infrastructure. They're an estuary, so it means that they are built on a river, not directly on the coast, but the river essentially feeds into the coast, and anything that happens in the sea is going to go right up the river and affect them as well. They have the Thames Barrier, which is behind some of the structures you see in the Netherlands. It's probably the best flood barrier that we have in the world, especially when it comes to movable. It's relatively new. They keep it updated. It's used on a relatively frequent basis, every couple of years, give or take, maybe sometimes a year, depending upon the weather. And they're also no stranger to flood events. They've had big-time floods and big storm surges throughout, the industrial period. As you can see, a few of the dates here, some of which you guys may be familiar, others not. Sorry if it's cut off at the bottom. And also, again, when you want to look at somewhere for social consequences, you have to take an interesting choice. And so right now, the United Kingdom has about 65 million people, or in 2017 they did, and they're set to grow by about 20% over to about 77 million through 2050. And a lot of this population resides in London. It's the biggest city in the United Kingdom, and obviously the capital of culture and economy and all this as well. So this is basically an engineering perspective of the Thames Barrier. I'll do my best to explain this with the lines. Not too important to get all of the details here, but essentially this is upriver. The water passes through here to go to the sea. So if there is a flood event or a storm surge because of something that happens or sea level rise, the water is going to come back this way. The barrier actually has a turbine that turns essentially a plate. It almost looks like a disc, but it faces this way, so it creates a vertical block here. And it can essentially block the water from passing over the top. Many of these turbines, I don't exactly know how many, maybe 12 or more, line every so many meters essentially across the River Thames to create a full barrier wall. They can essentially cover up to 6.9 meters, so almost 7 meters is the maximum surge level they can protect. If water was to eclipse that, it would clearly go over. And also, that's just for a surge. That's essentially, if that's a short-term period, they could stop the water. We don't know how long it would hold up under constant pressure because we've never been tested like that. So this is the data points for how many times that the Thames Barrier has been closed, basically since operation. Started operation in the early 1980s, I think 1982 to be specific. And as you can see with this trend, it's clearly been going up over the decades. The green is the combined tidal and fluvial, and then the blue is just tidal, so don't worry about that. Basically, just look at the green. It's the total number of times that it has had to be closed within each 2-year period, or I guess 1-year period. So this is also climate change at work a little bit because things have progressively gotten a little bit worse in the last 35 years. So here's the study area for this. This is a snapshot of Greater London, essentially the county of London. The orange barrier on the outside is outer London, while the lime green barrier is inner London. The blue line is essentially the River Thames and its pathway through the city. You can't see it, but right here is a little red dash, and this is the Thames Barrier itself. Built a little line to represent it. And all of the little colors and everything, this is the area or the geography of choice for the study. In America, we use census tracts. It's tracked by the government. Every 10 years we do a census. It shows a lot of data for each little boundary. And they have something similar in the UK. It's called Lower Layer Super Output Area, LSOA. I'll explain the details of what each one means, but basically it's just a little chunk of population. And the population density, this is for 2011, so just 8 years ago, the most recent census. And you can see the total population as it gets darker. That's where the more dense pockets of people live within the city. So this is our current climate change outlook, or at least as of 2 years ago. Again, you may not be able to see the text, so it's not a lot. I'll just read it for you really quickly. Essentially, this is from the IPCC, which is the International Panel on Climate Change. It's probably the best governing body source that we have as far as accumulating the world's best researchers and influencers when it comes to governmental policies and predictions on climate change. So essentially, for Europe in general, which is our general study of area, they listed the key risk of climate change for increased economic losses and people affected by flooding in river basins and coasts, driven by increasing urbanization, increasing sea levels, coastal erosion, and peak river discharges. This is a high confidence level for this one. And the adaptation prospects essentially come down to most of the damages can be prevented by adaptation, again, with high confidence. And a lot of this comes down to the flood protection technologies, increasing the flood protection, and then basically changing the way we have demand for Europe, probably through population control and other environmental and landscape concerns. Our biggest drivers are increased precipitation and sea level rise. And then this is a neat little chart that basically shows the differences if we act and the differences if we don't. If we do act, it's the darker lines. So you can see, again, the general timelines that I put through. This is in the present. We have relatively low risk of anything happening at the moment, and the same in the near term for the next 20 years. But as we get into the later stages of the 21st century, looking at different Celsius degrees warming, this is where you start to see big changes. And if we don't act, we can easily get into the very high risk as far as what our population will have to deal with. So again, this is the Thames Estuary Plan 2100. This is basically the formal climate change document that London is using to plan their projections, but most of their projections are, in my opinion, very inadequate. The highest thing they have on the scale is 4 meters of sea level rise, and they basically don't have anything that if that were to happen, because they don't believe it's going to happen. Again, referring back to the Hansen study, they're projecting 6 to 9 meters within this century alone. Most of this comes down to improving the Thames Barrier, maybe creating a new barrier, and some other basic strategies. It's not very detailed, it's not very thorough. This is essentially me calling them out for not being prepared. They're not taking this problem seriously, they're not looking at the science and the evidence we have. And this is London, this is rich Western world. If somebody's gonna be prepared, it would be London, right? It's not gonna be Africa, it's not gonna be Bangladesh. It's not going to be these other places that don't have the resources.
It does not surprise me whatsoever. They're so unprepared for everything.
You mean
Now,
the British do stupid stuff?
Yeah, but like we also just bury our heads in the sand about the consequences of our actions, so that does not surprise me.
Fair enough. This is the Thames Gateway Initiative. So this is essentially what you don't want to see. This is what essentially London wants to do as far as development. This is where the sea comes in through the North Sea into the River Thames all the way to downtown London. These are the areas they're trying to gentrify. This is a lot of old industrial places that they don't use the factories anymore, and etc. They're trying to turn to apartments. They have all these zoning and developmental strategies. So they're basically going to be putting a lot of people into harm's way because this is the place that's going to be affected the most. As the sea comes in, if sea level rises, this is what's going to be the lowest elevation, not as you get further upstream. So the red places are zones for change, and then the orange is just the total boundary of what they're looking at for this initiative. So this is quite scary because you want to be moving people away from this area and not developing in the zones most at risk. Also, the Thames Barrier is right about here, so basically everything east of the barrier doesn't have any protection at all.
Southwest, I'm good.
So,
I am on the brink of the
by the way, I wanted to go back to the Hansen thing because I don't think I had it on the slide, and I'm slowly coming back to me as I'm doing this presentation again. The reason why they are projecting 6 to 9 meter sea level rise is because in the late Eocene period where they were taking the snapshot of their data, the Earth was about 2 degrees Celsius warmer than it is now. Currently, and the sea level rise was about 6 to 9 meters, give or take on the period and you know what their projections are. They try to be loose in their things because it's really hard to be exactly specific when you're looking at this. Essentially with the IPCC and the Climate Change Accord, the Copenhagen, the Paris Agreement, all these other meetings that we're having that you hear about these summits every couple of years, the plan is, the global strategy for the Western world and essentially the rest of the world, is that we want to keep climate and global warming under or at 2 degrees Celsius. That's our limit. Well, the problem is even if we meet our benchmarks of what we're trying to meet, we're still looking at 6 to 9 meter sea level rise in a likely scenario. The problem with that is that given how much what we're doing, and when you actually look at the climate and what is already preheated in the oven, we're going to go past 2 degrees, maybe as much as 4 or 5 degrees. So we could be at double or possibly more. And that's if we don't make some radical changes. Obviously, we can't project. Maybe things will change in the next 10 years, some inventions, humans will get their shit together, etc. But what I'm saying is 2 degrees Celsius is a very conservative projection, and even at that projection, we're looking at some big problems. All right, back to the slide. So this is the data for the lower level super output area, LSOA, basically showing that in each of those little polygons that you see in the map, you have between 1 and 3,000 people and between 400 and 1,200 households. So this basically gives you a snapshot of what kind of data and what kind of scale we're working at on the population side. This is how I source my data. So essentially what I did was I'm projecting the sea level rise that we've talked about from Hansen in different scenarios, but I'm also projecting population growth because obviously there's going to be more people in London in the future than there is today. And population growth is really tricky to project because trends change, people can move, something can shift, there could be a war. I mean, there's just a million different reasons. So, Brexit. Exactly. So what I'm trying to do here is take empirical data. So look at what has already happened, aggregate it, and then project it in the future. I'm taking all speculation out of it as I can and just taking a raw numerical approach. So what I did was I took the five most recent censuses. So from 1971 to 2011, I took the population data, which is aggregate, and the boundary data, which is what those little polygons looked like. because they all shift based upon how people move around and how people essentially birth rates, death rates, the map never looks the same because there's always between 1 and 3,000 in each one of those things. So they have to essentially morph around to fit the map. So basically what I did was I took all 5 of the censuses, I stacked them all together in a nice spreadsheet. I aggregated out what the average growth rate would be if the same rate happened again for the future. And then I extrapolate that on into the 21st century. And then I used essentially geographic science to make the polygons accurate for what that would look like. I took a 50-meter elevation model, essentially digital elevation, to get the topography of what it would look like on the surface of London. And then I created the Thames Barrier as just a little polyline to show it on the map. So for my methods here, I essentially took what the projections were from Hansen. I did 3 sea level rise scenarios. 1 meter, which is very conservative, 5 meter, which is moderate, and 9 meter, which is aggressive. And I simulated them across 3 30-year intervals. So I wanted to project this out, again, from Hansen's projections throughout the 21st century. And that gives us a generational scope of kind of what we would look at in population growth as well. The geographic science, I'm not going to get too deep into it because it doesn't matter so much, but I used areal interpolation, which is basically I took the new area, which is 2011 and going forward, divided by the old area, and I multiplied the population. This allowed me to stay clean in the data and make it work going forward. And so essentially I had to have some caps on this because if you just took population growth in a 50-year sample, it's not a very big sample, and sometimes there'd be like a new apartment building in like an empty parking lot or something, and that growth would be off the charts and would mess up the data. So basically what I had to do was I would give it essentially it could never grow more than 100% in 1 decade, so that way it wouldn't be exponential growth. And I forget what the other one was, but I'll come back to it as we get to the next slide. And then I used a raster calculation to essentially project sea level rise on every little pixel in the map. So it's a very specific 50 meter by 50 meter scale of data. So previously they used enumeration districts, which was a different format of the polygons. They have since switched to LSOAs in 2001. So basically I had to marry these two because we have old data merging with new data, and this is the only way I could get the censuses to talk to each other. So it's, again, I never let it grow more than 100% in a decade, and I also never let it get beyond a max population density of what the most dense polygon was in 2011, which is almost 70,000 people per square kilometer, which is a lot of people. So clearly you don't want that all over your map because that's going to blow the data up. All right, so these were the results. So 2041, we have the 1 meter scenario. Again, it goes up as time goes on. So in 2071, we have the 5 meter, and then at 2101, the 9 meter. You can see the population basically from now up until 2101, it almost triples, doubling in this time frame. But I think the current population of London is something like 8 million or maybe less. So we're at 18, so like 2.5, give or take, just about. Clearly, the inundated population is going to go up as well as more and more land gets inundated with the higher scenarios. And then the area stays the same because London doesn't change itself on the map. And the same goes with the inundated area and the unique little polygons affected. So this is just the numbers. I'll show it to you in a map form. It'll make a bit more sense. So this is our first scenario, 2041. Same kind of looking map. The numbers change a bit because things get a little more dense than the 2011 I showed you before. But what you can also see is these little dark pools. This is essentially the sea level rise and what happens. In a 1 meter scenario, London's pretty good, especially because they have the Thames Barrier. So everything west of this line is obviously protected at 1 meter because they have a 7 meter maximum of protection. It's east of the barrier that gets hit, and it's really just the lowlands. This is not too bad. But this is also very conservative and in 22 years, so it's relatively recent, or relatively soon. Now when we get to the 2071 scenario, population has grown quite a bit. You see a lot more dark brown throughout it. And again, at 5 meters, the Thames Barrier is still holding strong. We're assuming it doesn't get crushed from that constant pressure, but it can hold up to a 7 meter height, so we're still good. Everything east of the barrier is where it really starts to hit. This is, again, the place where they want to develop everything, so this is not a good looking sign if they're really trying to put up a lot of apartments here. And then finally, we get into the aggressive scenario. So at this point, at 9 meters, the Thames Barrier is basically worthless. You're more than 2 meters above the barrier itself. And all of downtown London, all the abbeys, all the extra crap, it's basically underwater. It's pretty screwed. The eastern side the wetlands are pretty rough. This again would be a pretty catastrophic thing.
You still have 70 years.
Yeah, exactly. You have time. This is not going to happen overnight. But again, when I look at this stuff, this is what I'm saying. We can't pick up London and move it. London is where it is. There's all the infrastructure, all the history, all the cultural aspects of it, the economic aspects. I mean, it's impossible to just uproot London. But also, what are our other scenarios? Like, do we just displace all these people and abandon it? Do we get out of the way? Or do we try to out-engineer it? Do we just build more seawalls and make them bigger until we can block it all? What happens if they fail? Ask Katrina, or ask New Orleans when Katrina hit in 2005. They had a levee as well, and they were fine until it snapped, and then they really, really, really suffered. So, in my opinion, I don't think we can out-engineer nature. It's always going to find a way to win. It's a constant force. We can try for a while and maybe have some success, but that is not the answer. Clearly, the answer is trying to mitigate and essentially not cause this to happen in the first place, but that has its own difficulties from a social standpoint. So really, we're at a crossroads here. So the discussion with this is, clearly there's a lot of uncertainty in these projections. I'm trying to project data for 80 years in the future, and I'm also using it based upon several samples and a lot of variables, and I'm just one person. I'm not a master or a pro at this. I mean, this was my first take on any kind of science within this. But essentially, again, the message is clear. Whether I'm doing the research or anyone else, we all basically come to the same conclusion. We need robust adaptation measures. Most of us are not convinced that we're going to be able to undo the problem. I mean, as I said, we have 11 years in the most recent, high confidence calculations. And people don't change that quickly. I mean, 11 years is nothing. We'll have to completely undo our society and change how we're operating from an energy consumption standpoint. And that is a very, very difficult thing to do. I'm hopeful. I'm optimistic. I'm really pushing for that, but at the same time, I'm realistic. So if these are the kind of scenarios that may be at play, what we really have to do is start looking at zoning laws. So make sure we're not building in harm's way, like at least not create further harm that we know is going to be there. We also need to look at new barrier proposals, not just for London, but for other places, because if and until when we can figure out how to get a lot of this stuff changed, get people out of the way, or essentially reroute cities and do things differently, we need to protect ourselves the best we can. Also comes with that the formal relocation policy, which is, if this was London's future, like, what would we do? How would London figure this out? How would anywhere figure this out, right? You've got all these people, all this trade. We've got to figure out a strategy of where we could put them. How could we safely route them into new places, and what was the jobs going to look like? What's the public transportation going to look like? It's very messy, but there's a lot of work that's going to be needed to be done. And then also we need to continue to invest in research like this, because again, this is just a drop in the bucket in what the problem might be. And we need more dollars going towards this. We need more funding. We need more grants. We need more scholarships. We need more minds working on this problem. There's not enough money in this aspect yet, because essentially all the money goes towards the same problems that we already have. We really need to start investing in this as a primary source. Also, my suggestion is to go back and revisit the Thames Gateway Initiative and the plan that they had, because it's clearly bogus compared to what we're looking at. And then finally is looking at the raising public awareness. A lot of people know about climate change. They hear it. It's a buzzword, but they don't know like what's really happening and what this means. People need to know, because if we wait for governments to change and to make these decisions, it's generally not going to work out so well. We have to take matters into our own hands. We have to change the way we live day to day. We have to try to drive less and consume less. We have to live closer to places. We have to try to recycle more. We have to do all the little things that we can, but also vote with your dollar. Whenever you buy groceries, whenever you buy goods, whenever you buy clothing, whatever it is, that's essentially voting. That's how you can change the world slowly but surely. Spend money on companies and initiatives that are essentially doing good in the world and that are taking this problem seriously. But also make sure you're very smart and passionate about how you vote and what politicians that you put into office. Because again, 11 years is not long. That's only a couple terms. And we need people that are very progressive and that are taking this problem seriously to be the ones in the driver's seat when it comes to politics and governmental regulations. So make sure that you do your homework and you know who you're voting for, and you really get to the ballots and get to the polls and do your part. So again, I would like to see this compared to the citywide population projections, and not just one specific part in London, but doing it in other places as well. And then you also see the continued growth of inundated areas. Clearly, if we know that this is coming, or if it's happening and parts of this stuff is flooded, chances are they won't continue to build in the area. So that, again, this is basically my own feedback about the study, I can't really change the way I did the study to incorporate this, but people aren't going to build in where it's flooded. We already know this. There's also opportunity for methodological and data improvements. This was just a first go at it, but there's a lot of things that could be improved from an efficiency standpoint and also expanding on what already has been done. The other thing to think about is this is sea level rise. This is the slow burn. This is something that just slowly but yet permanently happens. This does not also take into account the fact that if there is a hurricane, I mean, probably not in London, but a storm surge or something like that would essentially bring in higher levels all at once. That is not the scope of the study, has nothing to do with that, but it's real, and it would obviously happen at some point, especially if climate change continues to do what it is within the ocean currents and the climactic system. So this is a whole separate ball of wax and something that is related, but completely different from the study, and would also have severe consequences. So the other aspects that we touched on a bit is like, what happens if the Thames Barrier fails? What happens if, we build more and we think it's good and they do that, and then all of a sudden it's not? That is a realistic scenario that has happened in many places all over the world. So it's something that needs to be considered in regards to our strategies going forward. And then there's also other aspects, like if we build the Thames Barrier and we build up this great wall and we stop all the water, well, essentially it's always up, it's always locked. So now you just can't use the Thames River. So what's that mean for London? What does that mean for trade? What does that mean for people? Because if you open that lock, the water's going to start to get through. It's not going to be so good. Maybe there's a way we could out-engineer that. It's possible, but that's also something to consider. As of now, the Thames Barrier isn't up most of the time, so you can pick spots and let boats go through and do what they do. This would be a problem if you were always facing meter level sea level rise. We also have the wonderful topic of Brexit. What does this mean? How will this change everything? How will this change how it's regulated? How will this change how many people are in London or in the UK? It's a very complicated topic that is beyond the scope of the study, but it's something that will certainly impact most of the things we talk about. And then there's also the bottom line. I think it would be nice if there was some way I could expand the study and try to do evaluation of projected damages. What's the real estate value of all the stuff flooded? What's the economic disruption? I mean, I don't know how I could get the data and put that together. It can be done. It's a little bit beyond my academics, but that's where it matters, right? Because you might hear, this happens in this decade and this many people, but until you see the number of the billions and the trillions or whatever it is in the end of what this would do, chances are most people don't want to act. So the conclusion of this is, I believe that the results support the hypothesis and that London is not prepared for what's about to happen, despite them being arguably one of the most prepared places in the world at this point. So really what this comes down to is a global call to action, and that we must aggressively reduce and offset CO2 emissions and prepare for adaptation strategies. There's basically no other way. I really want to be wrong about this. I'm sure I'm biased, sure maybe I've been swooned by the science or by the data, but I'm not rooting for this. I'm just very afraid, because this is what the smartest people in the world are doing to work on this problem. This is what they say is going to happen. And they have some great evidence, some great data that has been, aggressively fact-checked and double-referenced and peer-reviewed. And so this is essentially more of the cutting-edge things that most of the government and the TV networks and things don't want to show you. And really the long-term approach starts today. This is not just London. This is not a regional perspective. This is everywhere. This is Africa. This is America. This is Asia. Essentially, there will be some slight regional differences on sea level rise, but in generally, it's not going to be that different, and everybody's going to face this. So think about China. Most of their people are built on the coast. Think about, Oceania and Malaysia and Indonesia. Think about Florida. Think about all these places. I mean, some of these places are already under sea level. We have millions, billions of people in these places. That is beyond a scale that we can even wrap our head around of what this is going to do to society, what it's going to do to travel, what it's going to do to economies. This is incredibly complicated on what the consequences would be if this scenario comes to be. So this is something we really have to start thinking about seriously. I mean, it takes decades of work just to get our heads around the regulations. So I'm very, very concerned with what this is going to look like. This is the conclusion of the study. And so now that I've had 2 years, essentially post thesis presentation, I've been thinking about this a little bit differently and what this means for me and what it means for us as nomads. And so I've tried to think about this as far as a general recommendation standpoint. Obviously, we're not government politics. We can't write the rules. We can't change what we use as far as cars and fuel and all this stuff. I've touched a bit on what we can do as far as a day-to-day consumption pattern differences, and I still have a lot of thinking to do on that. But in reality, my recommendations are being a nomad is probably one of the best things you can do in this situation. because when shit hits the fan and starts getting bad, you can move. You're not location bound to one job that may or may not survive this situation with all the disruption that might happen. You also have the choice of where you go and where you invest in real estate. My recommendation is definitely do not invest in coastal real estate, especially in places in low-lying areas and places that are not well equipped. Again, some of the worst case scenario could be 50, 60, 80 years away. So maybe you could get by with investing for a while and selling it, upgrading it, or flipping it, or potentially getting out of harm's way. And that's possible. This is not a problem that's going to happen overnight for sure. But in general, what I'm saying is coastal real estate, if this starts to happen and these are projections, if this becomes public knowledge, PSA from our governments, this is what's going to happen, get ready, the value of those places are going to drop significantly because who's going to want to live there? So you never know when that might happen. You never know when the pendulum might swing or the tide might turn in public opinion, but that is something to think about. So continue to up your nomad game, be flexible, be mobile, get ready because we never know, when things might start to get quite bad. And also just pay attention to the things that you invest in for sure. Those are two big things I would say. These are the references I have, all the different studies and data points that went into this. There's pretty much most of them that we're using in this presentation. There's obviously a bit more. And now I'd like to open the floor to any questions you guys might have.
It's not, this is mainly about sea level rise, but since you're probably more deeper in this whole topic, one of the main arguments against this climate change thing is what I get is, the CO2 things, okay, it may be increased by humans from 200 something to 400, 500 parts per million, but it's just like, I don't know, 2% or 0.2% of the whole air we breathe and stuff. Why is the influence of CO2 that high? Why is it when it's just little on the whole air?
You're saying that, 400 parts per million is so small? Is that basically what you're saying, and why it matters so much?
Yeah, well, CO2 in general is I think it's 2 per mil or something. So really from the whole air, it's really close to nothing.
Yeah, and that's just has to do with the dynamics of our atmosphere. So obviously we've all heard the term greenhouse gases, and that's essentially the way that CO2 works. So essentially it gets bound up in layers of the atmosphere that keep the heat from getting out. It basically creates a blanket. Essentially what you have on planet Venus, they have a runaway effect with their greenhouse gases. So even though that planet is roughly the same size as Earth, their atmospheric composition is far different. They have way more greenhouse gases, and it's just like a super hot oven. I don't know exactly the temperature of Venus, but it's like 10 times higher than what it is on Earth. Basically, life can't sustain because it's too high. We have a smaller degree of this, and mainly because of what humans are doing, but essentially it creates a thermal blanket. So even though it doesn't take much to have this effect, obviously, 400 parts per billion is a lot compared to what we've had, but in regards to the total atmosphere, like I said, maybe it's only 2% of what's actually in the air. It's just very thermodynamic. Actually, what is even worse than CO2 is methane. Methane is something like 8 times worse than CO2 when it comes to its greenhouse gas effect. And a lot of this comes from the agriculture that we have, different livestock, farming, but also things that we're doing in the earth to release methane. The big problem is with a lot of this is that it's a runaway effect. It's a positive feedback loop, meaning the climate system and essentially warming, climate change and global warming, as we continue to contribute to it, it's a snowball effect that goes worse. Because when we heat the atmosphere and we heat the earth, more of our polar and Arctic ice caps essentially melt. And so those ice caps are clearly trapping water, right? They're holding water in a deposit, but they're also white. So they have an albedo effect, which is a reflection effect. When you take away the whiteness because it melts and you put into the dark sea, it becomes more of a darker color, which absorbs more of the heat. So it creates more and more warming, which melts more and more ice. There's also the problem of permafrost. So basically permafrost is all land that has been frozen for at least 2 years, constant freezing. Well, as the heating comes up and essentially it gets warmer in higher latitudes, permafrost starts to melt. And underneath permafrost, you have a lot of essentially trapped gases, basically from decaying vegetation. So when this happens, more methane, more CO2 comes up just from earth, just from soil composition and all these things. So as we heat more, then nature heats more. Basically, to get back to your point, it just essentially bakes it. It's kind of like putting a trash bag over the earth. I mean, it's a lot hotter if that trash bag's not on there, but that's what we're doing. So we're trapping more and more of the heat that we're generating.
So it's like, even if it's just a very small amount in terms of percentage, it's just concentrated in one layer and then it's like film around the earth.
Exactly. And the half-life, or essentially the processing time of what it takes for carbon to clear the atmosphere is It's in the matter of decades or centuries. I can't remember exactly which one, but we're creating it far faster than the Earth can displace it. So it's basically an accumulation factor. If all humans were to die tomorrow and everything stopped as it is, then the Earth would eventually return back to normal processes. It would just take many centuries for this to happen. But obviously, there's still nearly 8 billion people on the Earth doing their day-to-day thing, and then that bubble just gets thicker and thicker. That's a very layman's terms of how to explain what's happening. Anyone else? Any curiosities?
So the CO2 thing, because that's everyone focuses on that in terms of climate change. Is that the biggest problem? Like, does that drive everything else?
Yeah, I think so, because it's the one we're most contributing to. Obviously, methane is a bigger problem pound for pound, but there's far less methane going on than CO2.
Yeah.
So cars, shipping, transportation, airplanes, all this stuff. That's another nomad problem too, is we like to travel. And air travel is like one of the worst things you can do for climate change.
No, cruise ships are worse.
Maybe, but
you do less cruising than flying, probably.
I do, but a lot of people do.
A lot of, compared to flying.
There's many cruise ships. I mean,
That's
there's way
flying.
more flies, but planes.
and that's the problem. Like, we all want to have fun. We all want to live this lifestyle. We all want to go to places we enjoy. We all want to travel. It's important, right? Because not only is it fun and enjoyable, but the experiences that we get, they learn, they shape us, and who knows, they may contribute to something that we could give back to the problem. If we stayed in the same spot and never moved on this little isolated farm and did everything right, sure, maybe our little small percentage is doing good in the world, but is it changing the big problem? So this is the dichotomy, or the dilemma that I go through a lot is, okay, I know some of the things I'm doing are directly contributing to the problem, but if I stop doing them completely, how much does that change the problem? Not much. So yes, you want to be the change you wish to see in the world, but at the same time, you have to be realistic about your own personal impact. So it's a tough one, because I don't want to guilt shame myself into like being afraid of doing all this stuff, but at the same time, I want to do good and be good. So it's something I'm always working on in a personal choice. But yeah, I mean, it's complicated, and we all have to make a lot of changes is basically what it comes down to.
With the CO2 thing, because like in the UK by 2020, all the cars need to be electric, right?
Awesome.
So, or not 2020, it can't be 2020, it must be 2025.
It's next year.
Okay, I was wrong.
Yeah, no,
Like-
this. Yeah.
I can't remember exactly, but it's very soon that they're bringing this in. Maybe it's 2021, and it might be to do with the like where you can go and all this kind of stuff. Basically, the tax is going to be super high on anything that's not electric. My confusion, my concern about that kind of thing is the energy that goes into generating new cars must produce in itself pollution and destruction to the atmosphere, because you're putting so much energy into producing those new cars rather than just and then you're creating crap that like old cars that are just getting thrown away as such, because no one is kind of coming up with this engineering problem of taking the car that exists at the moment and changing it to be like an electric car, if you will. So what's your take on accelerating? So the way I see it, the UK are like accelerating the process and trying to force everyone to buy new cars so that they are electric cars, which is going to eliminate the CO2 problem, but it's going to generate so many other problems in my head.
Yeah, cars are probably the biggest problem we have, just because there's so many of them and so many people, for sure. So solving this problem is of paramount importance. It's not the only problem. We still have shipping, we still have agriculture, we have too much concrete that heats the earth up because it absorbs the heat, all this stuff. But I think that's a great way to think of it, because it's a systemic problem. Like this is why it's so complicated, right? Like, yes, if we switch over to electric cars, that's great, but now we have all this extra scrap metal, and unless we find really inventive ways to reuse it, now we start to have more of a pollution problem, and it's just this waste. Again, we still have plenty of space in places like landfills and junkyards. It's not like they're overflowing. Clearly, we don't want to be contributing to that, but currently humanity doesn't have a better way of doing that, at least sustainably. But yes, anytime you create anything, it causes industry, it causes consumption. So even creating the electric cars, we have to have the machines and the robots in the factories. We have to have the lights on, and that all comes from power plants, which generally comes from dirty energy. So you have to look at it from the top layer, you have to look at it from the bottom layer, and you have to try to solve each of them in between. And you have to do this in 11 years. So this is why it's like, ouch, like it hurts me to think because I know how much work this is and we've never done anything like this before, especially in that rapid of a scale. So that gives me a little more of realistic scenarios of what might happen. Yeah, I mean, it can be done every time we've been, humans are incredibly resilient, incredibly brilliant. Every time we've been faced with a challenge, we've survived. I mean, the fact that we're still alive now and we're the dominant species on Earth is fucking incredible, right? We survived, like, the comet impact that killed all the dinosaurs. We survived super volcanoes that have turned the atmosphere into night for months and months on end. In previous times, we've survived multiple ice ages, which basically killed so many people. We've survived plagues of bubonic plague and black plague and all this stuff that happened throughout history, all the wars, all this shit. So I want to believe that, you know, something will happen and we'll figure this out. It's just the problem comes down to the political inertia that we have and all of the resistance. Basically, the biggest problem is that corporations rule the world. They essentially have all the power because they have all the money, and they use all the money to influence politics. And we get people like Trump into office who won't even think climate change is real, and then they essentially create policies and tweak the laws to benefit these corporations, and the cycle goes on and on. And that's the problem, because we can't change without their help, but we can't get their help without getting them, you know, money. So it's a really difficult social problem in a way.
And their argument is always, no, we wouldn't be re-elected, it wouldn't be acceptable if we would do it.
Yeah, I mean, but it would be, you know, because if somebody starts to create positive, I mean, think about this opportunity. This is the greatest opportunity in the history of humankind. It's obviously the greatest risk we have. How many jobs will be created from switching our industries over? I mean, you have to engineer new vehicles, you have to engineer new blueprints, new cities. I mean, you have to put new train tracks and high efficiency vehicles. You have to change the way power lines are. You have to change new power plants. I mean, there would be so much economic output just to switch over. It would be an incredible boon to the society. Like this is a ripe golden apple ready for picking. The problem is they don't want to change. They have the death grip on fossil fuels and everything else, plastics and all the stuff that you see that comes essentially from fossil fuels. They don't want to give that up, and they don't care what happens because maybe they won't be around to see it, or maybe they don't believe it, or whatever. I can't get inside their minds, but they don't want change to happen. That's what it comes down to.
Yeah, but it's always also the people who would not only blame the politicians, for example, in this example. I think the solution is not to switch to electric cars. The solution is more reduce the number of cars, use public transport within cities, use a bicycle. You know, it's not.
Yeah, there's loads of incentives to do that already though in London. Like you have to pay an insane amount to drive into London, and these days, and everyone. There's incentives to use bikes, there's forest bikes all over London. Like, I'm not saying that there aren't any incentives to do that. The next thing they could do is basically ban cars from going into central London, but that's realistically not going to happen. But yeah, so now they're doing the electric car thing. The good news in Europe anyway is that the Green Party got an incredible amount of votes in the last European election, and they're like the most positive on the climate change side of things, but they've still not got enough to.
And you will be out of. You will be out of fuels. Okay.
What else would you do? No, I mean in general for the world, not for the UK. I mean in general for the world. Like there's definitely a positive shift in the way that people are thinking in terms of where they're casting their vote. Because the Green Party never used to really get that much attention, and especially in the UK, people are starting to vote for them because nobody else is making any fucking sense right now.
Yeah, I mean, I'm really hoping and crossing my fingers that Bernie is the next president in the U.S. He was who I was trying to get elected in the last run in 2016, and he is definitely the most progressive candidate that I've seen on the American side in my lifetime, and he's all gung-ho for combating climate change, so he will really start to uproot a lot of things. The problem is that history shows in America when we elect a progressive candidate, something like this, he just gets assassinated. They cut the head off the snake. So I would be very afraid for Bernie if he were to get elected and start making some changes that essentially corporate greed would take over and take him out.
Or you simply don't have the Senate, and everything that he's trying to do is blocked. You know?
Yeah, that's just one layer. It's not a full problem, but the president is obviously the key chess piece that you need, essentially.
So you mean actually get killed?
Yeah, I would.
Cut off at the knees like a bam.
I mean, obviously, it would probably. It's a possible combination of both. It depends on how much he's rocking the boat. But
So you mean nobody's gonna want to kill
I mean, I'm sure plenty of people want to, but I think he's pretty much got the corporations on his side, so he's relatively safe, I would imagine. I mean, again, this is speculation, but when you look back at people like Kennedy and Lincoln and some of these other great leaders that we'd had for different reasons, they were all taken out, you know, in a covert operation. So I have my concerns about Bernie because I think he would rock the boat too much. I love him, I'm rooting for him, but I'm afraid that even if he gets elected, it won't go very far. But
At least you got someone to vote for.
yeah, that's true.
Well, we literally have no one that's ready to lead our country into anything.
There was one other point I wanted to make there that was coming back to something that you guys said, and I lost it when I thought about Bernie. I can't remember if it was about nomading or what exactly it was about.
So do you fly
I remember
less?
now. What's that?
Do you fly less? Because you're-
I prefer to. I mean, I just started the nomad journey, so I've only had like 3 flights all summer, maybe, or something, maybe 2, really. But I mean, that's another reason why I want to be a slow mad is I don't want to be
But so do
contributing
you
as
really
well.
think that it's worse to take one flight every month than taking the car every day, 1 hour to go to work?
No, that's a better comparison.
Yeah, I don't know. I
The
mean,
thing is, if,
you
as
can science that for sure.
like as a nomad though, the chances of you actually taking, like you could do both, as in, so if you drove every day from work when you were back home, and you choose to be a nomad and you're flying just once a month, you could also just take a bus once a month, and that's definitely going to be way super less than the car.
Same with the commuting. You don't need to take the car. You can also commute with the train,
It depends.
or just move closer to your work.
It depends.
Yeah, but not everybody can do that because if everybody moves closer, then
Yeah,
there's
but
not.
there's also a point incentives in Germany, for example, that you get money for every kilometer you take to go to work and back home. You know, you get I don't know how many cents per kilometer per day throughout a year, and you get it refunded when you have your tax. You know, this is I mean it's ridiculous in my opinion. You get incentive when you live further away from work. I mean that's
Wow.
Yeah.
good question. Why?
But I mean, it's complicated, right? So when you look at that problem, yes, on the surface that looks like a bad decision because you're having to transfer more miles. But then when you look at urbanization and you look at the albedo effect of cities, when you start to build up in more dense and less green space because there's more concrete and more buildings, then that little area, metro area, it reflects more heat. It essentially doesn't have the vegetation, which is nature's buffer
But
to
I
sun.
think this is a good development that you have this urbanization, because at the end it's more efficient. You know, you have shorter ways. Everything is like in one place, and then it's distributed across the whole country. I think.
Yeah, I mean, it's
Besides, you're right.
difficult.
I mean, with the reflection and everything, and the cities are way more hotter than when you're here, for example. But I think at the end it's more beneficial because they are simply more efficient.
It might be, and in this discussion, we're talking about 2 of probably thousands of variables that really make up the bottom line of this discussion. So this is why it's so difficult to quantify. But I remembered the point that I wanted to make, and that essentially is in my opinion, the grand scope and scale of all this is, you know, the problem is we have too many people. We're overpopulated. We have almost 8 billion people on the planet, and by 2030 or 2040, I forget what it is, very near future, we're projected to hit 10 billion people. That's the problem. It's not that we have too many cows and beef and agriculture. It's we have too many people that are needing all this space. Cows aren't the problem. Cows have been around forever. They're part of the natural ecosystem. They create soil through their compost and their dung. If we don't have beef or ruminant animals, we don't have vegan food. Like, that's what the vegans get wrong, is they think we should just all eat vegetables. But if you don't have cows, you can't make soil to get vegetables. The problem is a numbers game, and the bubble is too big. Because we can't all eat and survive and cut down trees for toilet paper and everything else that we have that we don't think about. I mean, it's a consumption problem. So we need to shrink our population. If we don't do it through birth control, through conscious decisions, through, you know,
Third World Wars.
or something. I mean, I don't want that. I'm not saying anyone should have to die and suffer. That's not the thing. The thing is we need to be conscious, and we need to limit how many people we're creating in this world. We need to be smart about this, you know? And again, you could argue that's inhumane. If you start sterilizing people, or if you make some IQ test where only people above this level can have kids, then that's going to be very difficult, right? It's going to be a hard thing to implement. basically, if we don't do it, nature will, because nature will make sure that the population shrinks through a very difficult manner, which is going to lead to a lot of death, a lot of suffering, and a lot of stress. Nobody wants this scenario, but that's basically what it comes down to. We just have too many people. We have to shrink the people, because if we shrink the people, then all of the consumption goes down.
Do we have too
Good
many
thing that-
people because there's more people that they born? I think we have more people because we live longer.
Yeah, I mean, biohacking, right? This is all about life extension. This is all about being as healthy as we can be so we can create healthy babies and healthy next generation, so we can undo birth defects and all the plastics and chemicals and things that are in our environments that get into us that are causing infertility problems that are going out of control and all these issues. I biohack for performance, not just because I want to be the healthiest person or, oh, I'm paranoid or all this. Yes, hopefully if I have kids one day, I want them to be as healthy and give them a better biological foundation than what I had growing up. But at the same time, I do it because when I do this, I have more energy to put back into this problem. I can be a better friend. I can be a better lover. I can be a better entrepreneur. I can be a better researcher because my body is working the way it should. I'm not fighting inflammation and food cravings and all these things. That is why I biohack, to get the end result. But the problem is, like you said, life extension, medical advancements, it's giving essentially our lifespans are growing in most of the developed world. And because of this, it doesn't mean that in general the average person is doing more or contributing back to the problem. They're essentially just consuming more. They're still living unhealthy lives. They're still making poor decisions in regards to this scenario. And they're just adding more layers to the cake. They're adding more problems. We have to change. We have to change behavior. We have to change mindset. We have to change perspective. We have to change industry and society. You have to change government. You have to change a lot. This is the period of change. You know, you can get into this metaphysical, energetic, spiritual side of why is this happening? Why are humans going through this? Why is the earth experiencing this right now? Do we all live multiple lives? Are we all just souls that reincarnate from some other situation? Why are we all coming here to experience this at this time? Maybe there's some great lesson in the universal aspect of energetic, woo stuff. I don't know. I mean, obviously that is beyond the realm that I can measure and say. But I'm saying that this is like, in my opinion, the craziest and most awesome in both good and bad time to ever be alive on the human planet. Like, we've never had to do this before. So this is a challenge. This is something that we need to step up in whatever small or big way we can to figure something out and to talk about this and to evolve and grow through this. Because I think there's many lessons to be learned here, of course.
Do you think it would be beneficial to know how to sail for future preference?
Sail? Definitely learn how to swim.
Water world.
I mean, any skill acquisition is good, but that's possible, right? Sailing, I'm sure there will be some evolution of water habitat, above water habitats in some part of this. But then you have the problem, where does your food come from? I mean, you could eat fish and seafood all the time, and
It'll die out.
it might die out. Yeah, I mean, the oceans are heating up and it's getting more polluted and acidified, so maybe not. But
one animal of each, two animals of each species.
It's too fucking heavy for my sailboat. But yeah. No, it's a thing I used to joke around with.
yeah, I know my parents are getting close to the retirement age, and they want to buy a home in Florida. I'm like, guys, do not do this. But again, they may only be around for another 20 years or so maybe it doesn't matter. But at the same time, it's like, this is not a good recommendation. Trust the climate scientists in your family.
So how
Don't
long
go
do
with
you
it.
think it's gonna take?
I mean, it's all speculation. This is my best guess at this. It's in an ecological period. That's 80 years. So 21st century. You're looking at 2100. We're probably going to have 6 to 9 meters
80
of sea level.
years, none of us is gonna be here. Well,
I'm going to be here. I'm going to try to be here. But I don't know. I mean, yeah, we don't know.
fucking old.
We don't know. I
You
mean,
would not even be living in your house.
From this
You
point
would
of
be
view, you're right. I
living
mean,
in a
we can
retirement
really
house.
take the point of I don't care, because when it gets serious, I'm kind of old already. Maybe the last 10 or 20 years suck, but
see, and this is another issue. Is that this
This is.
a lot of people have this perspective, right? Especially people that are much older
just
than us.
her thought, basically.
No,
Yeah.
I'm not saying that you should
makes
not be
sense
caring
already.
about that. You should not be
Right.
caring about that. I'm just saying that,
And
okay,
She doesn't want to.
if that happened, you
From
should
that
make
point of view.
as good as you can do. But what I mean is
Appointment.
to buy a house next to the sea is not something that is gonna affect to you.
I mean, again, yeah, it's not going to just...
Timeline.
I mean, again, what the argument for this and for that is slow sea level rise. But what happens if you're close to the sea and a hurricane hits or something? Because there's more energy in the ocean and these things happen more intensely and more frequently before because there's just more energy in the ocean than there was before. So it doesn't have to just be sea level rise. That's just one significant chunk of climate change, but it is not at all the complete picture. I mean, there's so many other variables to consider that change everything. I mean, in reality, we should be using the term environmental change, because it's not just climate. It's going to change species. It's going to change, like how many things go extinct. It's going to change their mating season. It's going to change where they go for food, because the seasons of the earth itself changes. Growing seasons are lengthened. The summers happen longer in higher latitudes. Winters are less. This changes the way animals migrate. I mean, there's so much here to unpack. It's a lot.
And the point is, the Earth will survive, humans will survive. The only thing is like how, like, is it nice to live on this planet still? You know.
And how many, right? Like I certainly don't think that this is going to make us go extinct. Not completely.
I don't think so too. It just sucks. You know, there's an elite, like a small elite who has a fine life, and the like 90-95% really just suffer because like everything around you is just shit.
Yeah. I mean, the third world countries are going to be hit the hardest. They have no protection. They have no aid. When shit hits the fan, it's going to be like, well, let's all protect ourselves. Let's keep our money. Like donations are going to be less because people are just trying to survive because their jobs are going to be changed. The biggest problem I think that a lot of people don't talk about is migration. We already have issues with this. Look at what happened in the Middle East the last 4 or 5 years with all the wars and stuff. All those people were fleeing Syria and Jordan and Iraq, and they were trying to get into Europe because they had nowhere to go. And places like Italy would just let them die on the boat in the Mediterranean. They wouldn't let them in, and they would the little raft they had would sink. So this is a little grain of sand compared to how much migration we're going to have to deal with climate change, because people are going to have to leave because they can't grow food. There's going to be severe droughts in places. A lot of places are going to be underwater, like we're saying. Those people have to go somewhere. They're going to be pushing borders. It could start wars. I mean, this is going to get really messy. This is going to get really hairy.
Yeah, the next wars will be on water, not on oil.
Yes. Yes.
There's a great documentation from a German journalist, and it's in German, but it's really great. He went to a couple of countries like along the Nile, for example, or South America, and the army officials there, they really consider it as a scenario, as the main scenario they have to keep, will be future conflicts, will be water.
I think society would be best serviced if we could start putting in like child laws, like China did, where like one child policies and things to start shrinking population, like on a global scale. I mean, obviously the developed countries who have big populations for sure, but even third world countries, because they are not going to have the resources to deal with this very well.
A good level is also like fight poverty, because the richer the one is, he also uses more resources, but the less people or kids they produce. There's a direct relationship.
Yeah, I mean.
It's alright.
And the projections are at least that it will like peak at around 10 million, a little more, in like 240 to. Yeah. Billion. What did I say? Million? No, yeah, billion.
Yeah, and when I try to like look at both sides of the coin, both the climate change and the academic like environmental science, but then I also try to like think about it from a biohacking perspective, because that's probably my two strongest mental places, is that a lot of the biohackers, when they talk about stuff like this, they honestly don't believe that we're going to have an overpopulation problem. They think it's going to swing back the other way, and that's because of what we're doing to our genome, what we're doing to our environment. 1 in 8 American couples now have issues conceiving. They can't get pregnant. That number is expected to double in the next 20 years. So 1 in 4. You're talking 25% of people can't get pregnant. That's not necessarily a bad thing when you look at climate change, but it's also we're shooting ourselves in the foot, because we're going to be creating not the best, healthy humans. I mean, along with that comes the people that do get pregnant. There's going to be more birth defects. There's going to be more learning disorders and all these things that are just epidemically growing on a crazy level. Again, we need healthy, smart, active, brilliant people to be fighting this problem. We don't want to be making kids with, learning issues who can't contribute to this situation.
I think this will not have a big impact like in biohacking or in general, like good nutrition and stuff, because the mass, like let's say again 90%, they will just be fed with this like industrialized, high sugar, cheap produced food.
For
so
sure.
This I think is not a big issue that this will make all the people that live longer.
Yeah, I mean, it's not going to affect the grand scale. I mean, we can't really feed 8 billion people grass-fed meat because there's not enough land. So it's an elitist problem. In some ways it's greedy to eat grass-fed meat, but at the same time I know it's the best thing for me and the best thing for the planet. So just because someone in Africa can't eat it doesn't mean I shouldn't. These are the social problems and the dilemmas we face every day. But yeah, I mean, things like autism. Like I saw something the other day, by 2030, they said 1 in every 2 American kids will be on the autistic spectrum. 50% of kids will have some degree of autism in 11 years. Like I don't know, again, it could just be very mild autism, but essentially if it was anything significant level of it, those people are generally not fertile, they're not going to procreate. And how do we take care of that socially? How do you have enough caretakers to deal with millions and millions of autistic children? I mean, we already have an issue giving the people enough attention today. Those people can't work regular jobs. You know, society collapses if that is the true future of what we have.
Well, Japan is investing very, very hard in robotics just because they really think, and they are facing already that there's not going to be enough people to take care of poor people.
Right.
Japan is basically Europe, or specifically also Germany, like just 20 years ahead. It will be the same here.
Yeah, it will be the same
Totally.
everywhere, I guess.
It's a great topic. It's a great talk. Thank you guys.
Thank you.
I appreciate the discourse and the discussion. We need to have more of this. I know it maybe feels like it doesn't change anything in the big picture, but it gets people thinking. Who knows
Problem
what
is
this
the
could
bubble
lead to.
again, right? I mean, we are all interested in that, and we talk about the same, and we know more or less. Maybe we exchange some information that one doesn't know before, but like in the end, we are like also in a kind of a bubble. The question is how you can convince other people outside.
Yeah, but I think you have to believe that every generation below us is getting even more enlightened to this kind of thing.
We don't have time. That's a problem. We cannot wait for 1 or 2 more enlightened, for your kids and the kids of your kids. There's no time for that.
Yeah.
That's a
No, I don't
problem.
mean the kids of my kids. I mean the generations below me. Like, generation isn't everyone. Yeah, but like, I believe you need to look at things positively and realise that there are a lot of people becoming more switched on to this, and that the bubble, even though there is a bubble, the bubble is getting bigger, and that there are more and more people.
Yeah, as you said, with the elections in the European, last year, European
Yeah.
elections.
And
Because,
I mean, disturbingly, in the same elections, the Brexit Party actually got elected into the European Union, which is disturbing also, right? Because it should be.
Yeah. I mean, 11 years, anybody that's even born now, at 11 years of age, they're not going to be able to do anything regarding this problem. So
Yeah.
it has to be us. It has to be our generation. The problem is that it's our parents and grandparents who basically control most of the resources. They have the real estate, they have the pensions, they have the retirement funds, they have the stocks, the investments. That's where all the money and capital is tied up, majority. And they're still here, and they still have most of them still have the same stuck mindset of, oh, well, I won't be around, it won't matter, or just let me live my life. I just want to be comfortable, enjoy the years I have left. Some version of that. And so essentially until, in my opinion, they die off and we inherit those resources and have a chance to do something with them, that's when the real change will happen. The problem is if we tip the point before then, which we're running out of time. So, yeah, that's the conundrum that I see right there. Because those people still get to vote too, and most of those people are the ones voting for Trump and Brexit and everything else that's causing even all the delays of what we're dealing with.
They say now if you, like the same votes or whatever, like with purely on the basis of who's died and who's become of age voting, like if you just use the exact same like voting patterns or whatever and extrapolate it for Brexit, we wouldn't be in this situation. Like based on the last 3 years, and that's the switch that would have happened, is like just with the people that would have died and people that would have been of voting age. Like it would have been enough to shift it, because it was only 51 to 49.
So it's the last thing they did before dying.
Well, even like just, like obviously it wasn't them entirely, but just on a rough extrapolation in age, they say that's what it would have been.
Yeah, I mean, I guess my last point to be made would be, as dark and foreboding as this may seem, and it's frustrating, and you can attend a talk like this, and we can have this kind of discourse and get really frustrated, get really sad, we get really pessimistic. I mean, that's a very obvious and accurate outcome in many ways because of what that says to us. But I don't think that's the appropriate stance to take. I know that that's an initial reaction. I get it because that's a lot to process, and reality is very stark. But at the same time, like, what was it that the famous Winston Churchill quote, like never give up, like don't ever 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 give up, or whatever, some version of that. It's the same thing. Like, let's not just fold into this. Like, let's fucking fight it every single day in whatever way we can. I mean, be realistic. We all have regular jobs and other priorities too. Enjoy your life. Be happy. Don't let this consume you to the point where you get sad or depressed or just whatever. But at the same time, do what you can. Take it seriously. Be passionate. Spend your time, your money, resources. Engage with people on these levels. Like, we have to do whatever we can. Make it a calling card of life. And the more people we have of that, hopefully something good will come of it. That's all you can do. So cheers, guys. We must cheers something better to rather than the.
Creating better future.
Yeah, exactly. Cheers, Scott.
With the wine was flying here by plane, found